Here's the topology for the lab. 3 routers within the same autonomous system. Start on router 1 and configure the BGP process with an autonomous system of 65,000. Next, issue the command show IP BGP summary. As expected, there is no output. Now issue the command show IP BGP to view the BGP table. Again, no output. Make router 2 with the IP 12.1.1.2 an iBGP neighbor. Now, when you issue the command show IP BGP summary, there is output. We can see the autonomous system for the local router, router 1. We can see the configured neighbor, the neighbor's autonomous system number, and the up-down time, as well as the status or the prefixes received from that neighbor. With a successful peering, there will be a number here, even if that number is 0. The command to view the BGP table still shows nothing. BGP must be told which prefixes to advertise. The table is empty because BGP hasn't been told of any prefixes. Let's finish establishing the peering, and then we will return to the topic of prefixes. On router 2, configure BGP with an autonomous system number of 65,000. Configure router 1 as a neighbor. Issue the command to view the peering status. We see 0, so we know the peering was successful. Return to router 1. Take a look at the interfaces. Loopback 0's network will be injected into BGP. This is done with the command network 1.1.1 mask 255.255.255.255. Check the route table and see the host route for the loopback. That matches our most recent configuration. The associated network is the 1.1.1.0/24 network. View the BGP table. It's empty. This is because the network command used was incorrect. The host IP assigned to loopback 0 is not representative of the network tied to loopback 0. The network associated with loopback 0 is what BGP cares about. If a network is not in the table, BGP will not inject it into its table. Had loopback 0 been assigned an IP of 1.1.1.1 and a mask of 255.255.255.255, BGP would have respected it as a network and injected it. Make the necessary correction. We now have a prefix injected into BGP. The asterisk shows that the prefix is valid. A prefix can appear in the table and not be used if it doesn't meet all criteria. The next hop tells where traffic will be forwarded for the prefix. Router 1 injected the route, so it is the next hop. That is what the all zeros mean. Go to router 2 and view its BGP table. The next hop is router 1. This aligns with what we saw in router 1's output. Add the prefix to the end of the show IPBGP, and there's a bit more information revealed. Some of the information is the same as the previous command. Don't concern yourself too much with all the output. Later videos will go into details when needed. Router 2 is not advertising the prefix to any neighbors. Makes sense considering it learned it from its only neighbor. Make router 2 and router 3 iBGP neighbors. The peering looks good. Check router 3's BGP table. It's empty. It is peers with router 2 that knows of the route injected by router 1. Why has it not learned the prefix? Let's see if router 2 is advertising it. Router 2 is advertising 0 prefixes to router 3. BGP is working exactly as it should. Router 2 learned the prefix from an internal BGP neighbor. BGP rules state that a BGP-speaking router will not advertise prefixes learned from an iBGP neighbor to another iBGP neighbor. iBGP routers must learn the prefixes directly from the iBGP source. This means all iBGP routers must form peerings with each other. To learn about the 1.1.1.0 network, router 3 must be paired with router 1. Make router 1 and router 3 peers. Router 3 has now received the prefix from router 1. On router 1, we see the output from the advertise routes command. The quick reason for this behavior is that, like all protocols, BGP has a loop prevention mechanism. This mechanism is the ASN number. A router will not accept a prefix that has its own ASN associated with it. That is easy enough, but the ASN is only appended to a prefix as it is being advertised to an external neighbor. Internal routers have no way of using this loop prevention because iBGP neighbors won't append the autonomous system number when advertising to another iBGP neighbor. For this reason, iBGP neighbors must get the prefix straight from the horse's mouth. There's no loop if you get the information directly, alleviating any issues associated with guessing. Let's see this in action. Remove router 1 and router 3 as neighbors. Now make router 2 and router 3 external neighbors. You will have to completely remove router 3's configuration and reapply them with Autonomous System 65003. Look, the peering is up, and router 2 is advertising a prefix to router 3. Router 3 is no longer an internal peer, so router 2 can advertise what it learned from an iBGP peer, router 1, to an external neighbor. View the BGP table. Router 2 is now the next hop, and the autonomous system number is appended. If router 1 were to be advertised this prefix, it would reject it. Loop avoided. See that router 1 didn't advertise the prefix with the autonomous system number?